Okay, so today is the day I've been waiting for. I just love parallel and perpendicular lines because they just make so much sense to me. So let's first start by talking about what a parallel line is. So we're going to call on a couple of our good friends. Ooh, maybe we'll use the twins. Hold on. Let me get the twins out. Okay, we'll call this. There we go. Hello. Hello. Okay, so now let's say that the twins are traveling in the same direction, okay? Now, they're going to be traveling forever in the same direction, but they will never meet and their lines will never cross. Remember, this is what we consider parallel. When lines continue in the same direction forever, but they don't meet, they never cross, okay, they don't do that. Okay, they just continue forever the same distance apart. Okay, and that is what we mean by parallel. They are on the same plane, but they will never meet. Okay, so parallel lines will go on forever and never meet. So when we are talking about the coordinate plane and we have parallel lines, let's go ahead and draw ourselves a little coordinate plane here. Okay. Here is my lovely coordinate plane, and I'm going to draw myself a couple of lines. Okay. And I'm going to, let's see, we're going to put a dot there, and we're going to put a dot here. So 1, 2, 3, 4, 1, 2, 3. Okay, so here is this line. Okay. And I'm going to put a dot here. So that was 1, 2, 3, 4. Okay, and here I am drawing two parallel lines because although my friends were really helpful, they were not easy to actually see what's going on. So these are two parallel lines. You can see that they are equidistant all the way along. These lie on the same plane, our graph paper, but they will never meet, okay? So these are parallel lines. What we want to look at is our slope of our parallel line. If we come down and make our box here and make our box here, what we're going to find is that our rise, 1, 2, 3, 4, is the same as our rise here, 1, 2, 3, 4, and our run, 1, 2, 3 here, and our run, 1, 2, 3 here, are identical. So, with parallel lines, have the same slope. Okay? And that's it. That's all you need to know about parallel lines. That's the beauty of parallel lines. They're so easy. Okay, so let's say we've got, are the graphs they're going to ask us. So we've got negative 6x plus 8y equals negative 24. And we've got y equals 3/4 x minus 7. And the question is, are these parallel? Are they parallel? Okay, so what we're going to have to do is we're going to have to go ahead and convert this and say, well, let's look at it. Is it parallel? Okay, so I'm going to go ahead and move the x term to where it belongs. So I will add 6x to both sides. Okay, getting rid of it there. So now I have 8y equals 6x minus 24. Okay, but I need just one y. Divide it by 8. Okay, so I have to divide this by 8 and this by 8. This is going to give me my 1y equals, now 6 over 8, we know we can reduce that to 3 over 4x minus 3. And indeed, whoa, where is it? There it is, yeah. Okay, what you can see is that this slope is exactly the same as this slope. So you can say, yes, these lines are parallel. Now, what's different between them? Well, of course, the y-intercept. They're not the same line, so they're going to have the same slope, but different y-intercepts. That is really the whole thing with parallel lines. So, we're going to leave that. We're going to move on because I trust you to be bright young people. And we're going to now talk about perpendicular lines. Now, I also love perpendicular lines because they are also very easy. Okay, I am going to bring out the twins again because perpendicular lines, if you remember what perpendicular is, basically, perpendicular lines will intersect at a right angle. This is how we know they are perpendicular, when they intersect at a right angle. And you can see pretty much that we have a little bit of a right angle here with our twins. Okay, so that is perpendicular. Now, when we look at perpendicular lines, there is a special way of just quite simply getting the perpendicular line. Let's start with, let's go this way. Let's start with this line. We'll take this and we'll take this, and let's see what happens there. We have a couple of points. Where is, oh, no, I don't know. This one, and let's see this point. That'll be good. Okay, so here is my starting line. Okay, now I'm going to go ahead and find my slope. So I've got 1, 2, 3, 4, 5, 6, 7 here, and I have 1, 2, 3, 4, 5 here. So my slope, let me move down a little bit, my slope is 7 over 5. Okay? Now, all we need to know for perpendicular lines is that perpendicular lines have a slope that is the negative reciprocal of, oh, can't see it, here it is, of the original slope. Okay, so it's the negative reciprocal. So if I have a slope of this line of 7 over 5, the negative reciprocal is going to be negative, because this is positive, negative 5 over 7. Okay, so let's just use one of my points here, and I've got, well, that's actually better, but we're going to use this point here, okay, and we're going to take a slope of negative 5 over 7 from our top point here. So from here, I'm going to go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, going in a negative direction. And when I put my ruler up there, I see that I have got now a 90-degree angle, okay, and I have created the perpendicular line to my original line. So that's really kind of it. Negative reciprocal, got to just remember, if your original slope is positive, then your perpendicular slope, I can't say the word perpendicular. The perpendicular slope is negative. If your original slope is negative, then your perpendicular slope will be positive. And then you just have to take the reciprocal of your original. So let's go ahead and just say that we have a slope. Okay, let's say our slope, let's see, we're up here. Our slope is 5, okay? Then our perpendicular slope is -1/5, okay? If our slope is 1/2, let's say -1/2, okay, then the perpendicular slope, perp slope, is a +2, +2, okay? That's all there is to it. I know you guys can handle this really well. So that's it. Hope you enjoy the video. I'm turning you off.